Okay, so we're going to get started here, and I guess I should turn on the see what the essential question is. Actually, we're not starting out with an essential question today. We're going to start off with some vocabulary when it comes up. Okay, first, I'll just go ahead and tell you in here. The first word is exponent. We will have an essential question, but it's coming a little bit later. So the first word is exponent. There you go. So just give me a quick check when you have those three words down if you are on the other end of things. That way I know you're done and ready to go. Looks like everybody's ready. Okay, and so just a couple things about exponents. Just make sure you get your name tag. And okay, so these are some things we need to know about exponents. First of all, there was the vocabulary for exponents that we talked about, that we had up there. Base, exponents, base, power. And what you need to know before we get started is that the entire thing here, this whole thing, is called a power. So a to the n, that whole thing is a power. 5 to the third, the whole thing is called a power. Now when we're looking at that, it says the a and the 5 are considered the base. So this part right here, that a and that 5 are considered the base. Next thing is that the n and the 3 are called the exponents. So this n right there is an exponent, and the 3 right here is an exponent. So you're getting some information about what those things are. And then I noted that the positive integer tells us how many of the base are being multiplied. So, the positive integer exponent. So if I have 5 to the third, that exponent, that positive 3, tells me that I need 3 5s. You can see that 1, 2, 3 5s, and I'm multiplying them. And so I know this is kind of a review for most of you, but that's okay. And then if you have 7 to the 5th, that exponent, that positive exponent, it's an integer, okay, tells us we need 5 of those, the base. So 7, so 1, 2, 3, 4, 5, 7s. And the last thing you need to know is exponents can be positive, negative, 0, or fractions. Okay, you guys have pretty much mostly dealt with probably positive exponents to this point. You may have had a little bit in 8th grade about some negative exponents with a 0, but you may not remember some of that. And then there's fractions. We're not going to deal with the fractions today. So when you've got this down, go ahead on the other end, give me a quick check mark, and check around here for everybody else. One of those things that we're actually seeing that this information next to like where the word power is, next to the basic and then it's kind of together. It's thinking. Clear this end. Here's mine. Okay. So, in front of you, you should have this page. There's actually 3 pages there, and this is one of 3 pages. And so we're going to look at this, and we're going to work with this for a couple minutes. And what we're going to do, what I'm going to ask you to do is I'm going to ask you to fill out the expanded notation piece, and then over in this section here, you're just basically going to put the answer to what those are. But expanded, what that means, so like down here at the bottom was 2 to the 3rd power, right? So that would mean 2 times 2 times 2, because if you're looking at 2 to the 3rd, remember that the exponent tells us we need 3 of whatever the base is, and I'm going to multiply them. So I have 1, 2, 3 of the base, which is 2, and I'm multiplying them. And then over here, we're going to put the actual solution. Okay? So I want you guys to work on that. You guys can kind of talk about it in your group. Okay? Once you think about it and think about other patterns, think about other patterns that you see in the table that might help you, that kind of thing. So, and then but I did put an announcement and said if you want to talk That is this number negative? So this is the same 3 plus negative 2 plus Okay, so one of the things that, just so for people in there know, that people have tried for this section here, that part right here, is they said this times this times this. Now the question that I'm asking is, if this is saying 3 sets of positive 2, then that has to be a positive 2 here. If this is saying negative 3 sets of positive 2, then can the numbers here be negative 2? Because this is saying negative 3 sets of positive 2. And the answer is no, because it has to be a positive 2 based on what we know about bases and powers. So this isn't going to work. That was a good pattern that everybody thought about, but that's not what it means. So let's see if you guys can find another pattern that might work. So look at the patterns you have for the positive numbers, see if there's a pattern that's happening. All right, so a lot of you kind of caught on to this. So what you put here was 2 times 2 is 4. And a lot of you noticed that there was 1 less 2 going from the bottom one to the next one, right? Okay. And for this one, there's 1 less 2, right? That I'm multiplying. So I get 2. Some of you actually put 2 times 1 here, and that was actually very intuitive for you. Because if there's, for the every time we're going up, we're losing a 2, right? In the expanded notation column. So if I lose a 2 from this one right here, what would I get? What would be left? If I lose the 2 from there, what's left? The 1. So that's one way to think about it. Because if there's always that times 1 you can put on there, right? And it doesn't change the number. Does it make sense? Okay, so I could have had a times 1 on the end of each of these. Okay. But if I lose the 2 from here, I'm going to get left with the 1. Now, what's happening as I go from here to here? If I'm losing the 2 and I'm multiplying, what would I actually be doing mathematically? If I'm losing the multiply by 2, I would be doing what? Dividing by 2. So if I say 8 divided by 2, I get 4. If I say 4 divided by 2, I get, if I say 2 divided by 2, what do I get? I get 1. Okay? All right, so now that's the pattern that's in the table, isn't it? So how do I continue that pattern? I continue dividing by 2, right. So if I divide by 2, I would say 1 divided by 2, which is just a fraction 1/2. Okay? All right, so you're planning on staying about 25 minutes into the next class, right? Okay? And so right here I'd write 1/2. And actually, if I just have 1, 2, how do I write that as with an exponent? 2 to the 1. So I could say this is the same as 1 over 2 to the first power, can't I? Okay. So what did the negative cause us to get? Cause us to get a fraction. So when I see a negative exponent, that means I'm going to get a what? A fraction. Okay? And that fraction is going to be 1 over. So the negative 1 means I'm going to write 1 over, and then I look at the symbol here, or the exponent here, and it's a 1. So it'd be 2 to the first one in the denominator, right? Okay? So what if that 2 to the negative 2? What is that going to be? It's going to be 1/2 times 1/2, right? It means I need 2 of those 1/2, 2 of those fractions. And so that would be the same as 1 over 2 to the second power, right? Which is the same as 1/4. Okay? And so the same thing. Can you guys fill in the last one? Now that you see what the pattern is? Pardon? Oh, does James have a question? Thank you for letting me know that. Okay, good thought. Okay. All right. So go ahead and fill in that last little piece there. What would it look like? And I'm going to ask you one other quick question. Based on that, what if I had this? What do you think I'd do with that? Let's think about what happened with these. When it was the whole number part, and this one was here, it made this go to the denominator, didn't it? So what do you think might happen since it's in the denominator right now? It's a negative exponent. Yeah. Yeah, exactly. It's going to move to the numerator. So this would be written as 2 to the positive 3. Like that. Okay? Based on the patterns that we've seen. So math is all about patterns and seeing those patterns and finding those patterns. It's not magical or like that. Okay? Questions about that? Everybody got that down? We'll come back and so our next thing is, here's our essential question. I didn't want to give away our activity. So let's get that down. And give me a check mark on the other end when you have those down. talk with your group about why does x to the 0 always equal 1? So no matter what number we put to the 0 power, it's always going to equal 1. Why is that? Yeah, but why is it? Based on, go back and look at your page. See if you can figure out why it's that way. And think about why would any number to a negative exponent become a fraction? And I should have put on this when m is positive. So when m is greater than 0. Let's think about it. What does that 0 mean? It means there's no x's, right? With our 2's, it meant there was no 2's. But what number was there? No, look at your paper. Look at your paper. Yeah, if there's no 2's, the number that was still there was that number. There's no 2, what number is still there? 1, right? If you multiply by 0, we wouldn't have anything, right? What you tell me, look at your pattern. No, if it was 3 to the first power or 3 to the second power, instead of dividing by 2, you would be dividing by 3 because 3 is the one that's building, right? Okay, it's a good question. Anybody else? Does that make sense to everybody? If it was 4 to the whatever power, and you were going between powers, you would be multiplying or dividing by 4, right? And so you get to that last one, 4 to the first, to get to 4 to the 0, you'd be dividing by 4, right? Which would give you just 1. Okay? And why does it become a fraction? Yeah, why does that negative exponent make it a fraction? Goes back to what we were just saying, doesn't it? You're still multiplying or dividing by whatever the base is, right? And if you continue multiplying and dividing beyond 0, the 0 exponent, you're going to get that fraction. Okay? So you guys have the answer to that. And unless you take a second to jot that down. And here's a good explanation. So if we have a 0 exponent, like 5 to 0 equals 1, it means that there are 0 5's that are being multiplied. There are no 5's being multiplied. But since anything multiplied 1 doesn't change the value, we can think of it as 5 to the third equals 1 times 5 times 5 times 5. If there are 0 5's, we still would have a 1, wouldn't we? Based on what we see in that. That's another way to think about it as well, isn't it? So there's a second way to think about it. And then for your negative integer exponents, 5 to the negative third means the same thing as 1 over 5 to the third, or 1 over 5 times 5 times 5. So that negative integer exponent indicates a fraction. Okay, it's like got that copied down and they're ready to go on. Okay, so I do 2 more here, and then we're going to move on. I need to come back to this to get it at the end, so I can flip it back up. I don't know, this is important to put it there. All right, so the next page you have has this and another one on it. So what I want you to do on these is I want you to write them out in expanded notation like it shows, and I'll give you an example, what that means, and then write down what the solution would be. So what would the solution for this one be? And that's because we have 1, 2, 3, 4, 5 A's being multiplied, right? So it would be A to the 5th. And I'm going to go ahead and show you the next one, because I'm going to ask you to do these, kind of go through these pretty quickly, and just and then think about what's the rule. So let me show you the next one. So like this one you'd write out like that, right? So what would the solution for that one be? X to the what? Okay, good. That's exactly right. Because I have an x over x, which makes 1, right? Another x over x, which makes 1. So all that's left is just 1x. Which is x to the first, because there's only 1x left. And it's in the numerator, which is just x. Okay? And then you've got the other couple. Just do a couple on each page right now because of time. For each of those, make sure you write them out. And then we're going to take a few minutes. I'm going to give you about maybe 5 minutes. And then we're going to talk about the rules on these. So you can figure out what the pattern is. What's the rule? Figure the pattern is. Can you get done the first one of the problem is to the solution without having to write it out in the notation? What will we do? Go ahead, your 2 pages, go ahead and make both of them. You got the first again, start with them. All right. Let's go back. Direction. Okay. So when you did this, let's kind of check over what we got so far. Everybody good with that? This is one you've kind of worked with before, isn't it? It's not quite as challenging. So what do you guys know about the rule here? How can we get from here to here? Yeah. You guys hear what was just said there? She said you're going to do what? Add the exponents. Can you see that? So this means I have 3 of these, and I have 2 of those. So if I have 3 and 2, then I put them together and I have 5. Okay? Now, I'm not so worried that you have that rule memorized as much as you understand what's happening here, because if you understand what's happening here, you can think your way through it and always get to the answer. All right? So I'd rather have you understand what it means or what it looks like when it's written out. And eventually you'll kind of get it in your head and work it out that you know from here to here, I've got 3, then I've got 2 more, so I've got 5. Okay? I've got 2 and I've got 6 more, so I'm going to have 8 of them. All right? Let's look at the next one. Most of you did a good job with that one as well. Okay? So you wrote those down. And most of you've got the -5 and got the 5x's in the denominator, which is really good. The other way to write this, remember, would be this way. Okay? And most of you got these. And the reason that these bottom 2 were negatives is because the x ended up in the x we were looking at ended up in the denominator, right? So you can write it as negative with a negative exponent. Most of you got that. So what's the rule here? How do I get from the first one to the last one? If I'm taking things off, what would I be doing? I'd be subtracting, right? So every time I match, so here for this first one, I've got 3 x's and I match that with 2 x's to make 1, right? So if I'm matching, I don't need them to make 1, I don't need them anymore, so I'm taking off the 2 sets, right? Here, I'm also taking off 2 sets. Here, I'm taking off 3 sets, and I'd say 3 minus 7. 3 minus 7 is going to give me -4, isn't it? Okay? And 4 minus 5 is -1. So I'm taking off the 4 sets. Does that make sense? Because I'm taking off the 1. Again, but do I want you to memorize that you're subtracting? And I'd rather have you make sure you understand this part here and be able to work your way to that number. Okay? What about this one? Most of you did a great job of writing these out. But you struggled a little bit more on how to write the solutions, and that's okay. So basically, I'm looking at that, and I looked at all the a's. How many a's were there? There's 4, so I'd write it as a to the 4th, and there were how many b's? There's 4 of them, right? So I'd write it as a to the 4th, b to the 4th. So what happened with this exponent? That exponent went to each part, didn't it? It's kind of like distributive property with an exponent, right? The exponent has to go to each part that's within the parentheses. Okay? So when you get to this one, I took the exponent to each part, 3 to the 3rd, x to the 3rd. The 3 to the 3rd is the same as 27, so I can write it that way, x to the 3rd. The next one, I took the squared part to each part, so it's -5 squared would be 25, wouldn't it? And then x squared, y squared. So I took this to each part, including the number. And since the negative was in the parentheses, I said negative 5 squared. Okay? And this last one, there's a couple ways you can write it. You could write it that way, but some of you wrote it differently, and you were perfectly correct. How did you write? What's the other way to write that? Absolutely, using that idea of that fraction, the negative exponent in the fraction, right? So that's the other way you can write it. All right? Both ways work, and sometimes you need to do it both ways. Okay? What about the last one? How do we do with that one? Some of you may not have gotten to it. So what does it mean? Yeah, this means we have 5 sets of that, doesn't it? If I do that, I've got 2, 4, 6, 8, 10 A's, or don't I? So that would be the same as, yeah, 8 to the 10th. What about this one? How many x's would we have for the next one? If I write it out like that, how many do I have? How many do I have? 12. I've got 3 4s, don't I? 3 4s means I have 12. Okay. And I could write it out so I should see all 12 of them. Except I didn't, because that gets to be long, right? So that would be x to the 12th. So what would the next one be? Quickly tell your neighbor what you think the next one would be without. What do you guys think? Why are the 6 to the 4th, the whole thing's the 4th power? How many y's do we have? Well, here I've got 6, but then it says to the 4th power. How would that be written out? Think about how that would be written out. I would need 4 of that thing in parentheses, wouldn't I? If there's 4 of those, how many would I have? How many do I have? Okay, and then the last one, I have to write it out. So think about what the rule is for this one. Okay? I'm going to skip over a couple because you guys kind of already did some of these. And here's our summary. So make sure you have this down. So because here's those rules that you guys just came up with. You guys figured all these rules out on your own. So here's your summary of that. And once you have that, and know you've already kind of done the essential question, make sure I get your name tags. Put them back here on this desk right here. And you're good to go. And hopefully I'll see a bunch of you guys tomorrow, Friday. At least I'm going to be here the first hour. The second hour I have to teach class, but okay. Yes, those are reminders for you.